Okay, so question one of our second midterm was a question about finding the angular speed of a planet as it's going around a star of mass m. This was a question where speed of the planet going around that mass was something that had an explicit formula in the book that could have been on your formula sheet. But we wanted angular speed. The symbol for angular speed is omega. Omega is related to linear speed by v over r. And so here we have a problem where we have a mass. What forces are acting on it? It's a problem in circular dynamics where we have just a gravitational force acting on this mass, pulling it towards the center. So the force acting on this mass is gm over r squared. And what that's doing is it's causing this object to go around in a circle, in circular motion. And so this object is going around in uniform circular motion. This is the case of uniform circular motion. And for an object in uniform circular motion, we know that the sum of the forces acting on it is equal to mass times acceleration towards the center. And that acceleration towards the center we sometimes call centripetal acceleration. It's given by mass times v squared, speed of its object divided by r. And if we substitute in the speed of the object being the radius of the object times the angular velocity of the object, we can express this as mass times one of the factors of r will cancel times angular speed squared. And so now we have an equation that has m on both sides, little m. So we're going to get a result that's independent of little m. And so canceling the factors of m, we find gm over r squared is equal to r omega squared. And we're trying to find what omega is, the angular speed. Omega squared is equal to gm over r cubed. And that's equal to, well, and so omega itself, angular speed is equal to gm over r cubed, all square rooted. So we look through our answers, and on the group test, this was answer D. Of course, so everything I was doing was off the screen apparently. So gm over r squared, once we've canceled those masses, is equal to r times the angular speed squared. The angular speed squared then, if I divide both sides by r, becomes gm over r cubed. If we take the square root of both sides, we get square root of gm over